Now, the topic of discussions of today is the distributed mutual exclusion. Uh, what happens before that, we should learn what is mutual exclusion, because uh, in the problem of mutual exclusion, there are concurrent accesses of the shared resources by several uncoordinated user, and therefore it is necessary to serialize the requests from the different users for the shared resources, just to maintain the integrity of the shared resources. So it is also required that whatever actions which are performed by the user as far as the shared resources are concerned, they must be atomic. Meaning thereby, if there are several users and they are concurrently accessing the shared resources, uh, the actions which they used to perform, the action which is performed by an individual user in respect to the other users are concerned, it must be instantaneous, so that the net effect on the shared resources should be in such a manner that the user's actions should be executed serially and not to be in the interleaved manner. Now, the problem of mutual exclusion, it arises very frequently in the distributed system, because whenever the concurrent access to the shared resources by the several sites uh, are required, the mutual exclusion problem may arise. So just for avoidance of that, just for the correctness of that, it is always necessary that the shared resources which are available in the distributed system should be accessed by a single site or by a single process, one at a time. Now, since this kind of problem, which is problem associated with the mutual exclusion, uh, it is a fundamental issue as far as the design of the distributed system is concerned. And the design of the distributed system should be done so that it will be efficient. It should be some techniques, some robust techniques should be adopted, so that the whatever we are going to design the distributed system, it is going to be resolved as far as the problem of mutual exclusion is concerned. Now, if you compare the problem of mutual exclusion in the single computer system with respect to the distributed system, as far as the single computer system is concerned, in that case, the shared memory exists, and the status of the shared resources and the status of the user is uh, readily available in the shared memory. And the solution of the mutual exclusion problem, it is easily implemented, can be easily implemented using the shared variables, for example, such as semaphore. But in case of distributed system, it is more complex. The problem of mutual exclusion is more complex in comparison to the single computer system. Because why it is so? Because we are lack of shared memory. We don't have any common physical clock, and there is also possibility of the uh, unpredictable delay of the messages. So uh, it is virtually it is impossible for a site in a distributed system to have current and the complete knowledge of the state of the system. So So uh, now the classification of the distributed mutual exclusion. Basically, the uh, distributed mutual exclusion is classified into two parts. The algorithm which is developed to solve or resolve the mutual exclusion. So the algorithms which are developed for the distributed mutual exclusion are based on the first kind of algorithm is based on token based algorithm, and another one is the non-token based algorithm. And in token based, we have two algorithms: Suzuki Kasami broadcast algorithm, and second one is a Raymond tree based algorithm. In non-token based, we have Lamport's Ricard Agrawala algorithm and the Macquart's algorithm. So, however, there are a lot of algorithm which has been developed uh, for the for resolving the solution problem of the mutual exclusion, but there are different types of communication topologies. There are different types of the amount of the information which is maintained on the sites are also different. So that is why uh, the algorithm has been classified into two ways. One is token based, in which the system will be working on the base of the issue of the token. If any processes is going to possess the token, then only that process will be going into its critical section. Otherwise, the rest of the process has to wait. So at one time in token based system, at one time, one process is going to going to execute its critical section whenever it possesses the token. The non-token based algorithm is basically based on the timestamps, and token based is based on the issue of the token. So we will discuss this different kinds of algorithm later on, but we should know what are the preliminary requirement of those algorithms. Now, as far as the system requirement of the mutual exclusion algorithm is concerned, uh, the primary objective of the mutual exclusion algorithm is to maintain the mutual exclusion so that it is going to give you the guarantee that only one request accesses the critical section at a time. This is the primary objective. With this objective, there are four requirements. The first requirement is free from deadlock. Free from deadlock means two or more sites should not be endlessly wait for the message. That will never arrive, meaning thereby, uh, whenever we talk about the free from deadlock, deadlock means infinite time. The sites who has sent the request to go into the critical section is not getting any kind of privilege or the acknowledgement, and are in wait state through the indefinite time. So that is known as that freedom from the deadlock, meaning thereby the exclusion algorithm must be in such a way, it is should be implemented in such a way that the sites should not wait for indefinite time. The second requirement is freedom from starvation. Starvation means a site should not wait indefinitely while other sites are repeatedly access the critical section. Meaning thereby what happens that a site is forced to wait indefinitely to execute its critical section, while the other sites are repeatedly executing the critical section. So in that case, every requesting site should be given an opportunity to execute the critical section within a finite time. So what happens in this case? The algorithm should be designed that it should be free from starvation, meaning thereby if one site has requested one time, two times, three times, four times, uh, there should be, it should be in such a manner that if the control is being given to a particular site to repeatedly access the critical section, it should be avoided, and the chance should be given to those sites who are frequently making the request for going into its critical section. So the difference between these two is deadlock means indefinite time and starvation means some definite time. Now, as far as the strict fairness is concerned, the algorithm should be designed in such a manner that it should show the fairness. Fairness means that request has to be served in the logical order, in the way which is going to arrive. Suppose there are 4 requests in the queue. So first request should be handled, then the second, then the third, then the fourth. And it should not be so that only first request is going to be served, only second request is going to be served. So sites who are making the request should be given equal opportunity for going into its critical section. So there should be fairness. And the last one is the fault tolerance. So algorithm should be able to detect and recover from the failure or the faults. It should be fault tolerant. Fault tolerant so that it in the wake of the failure, it can reorganize itself so that it will continue its function without any disruption. So these are the 4 basic requirements as far as the mutual exclusion algorithm is concerned. So we must have a simple solution of the distributed mutual exclusion, and the simple solution of the problem is that what we do, we can make a site which will be working as a control site, and it has been assigned a task for granting the permission for the CS execution, that is critical section execution. And to request that critical section, a site sends a request message to the control site, and the control site queues up all the requests for the critical section and grants them permission one by one. But now this method of achieving the mutual exclusion is in the distributed system requires 3 messages per critical section execution. One, request message. Second one is the privilege, or you can say acknowledge message. And third one is the release message. So, but this solution, which is called as a centralized solution, it has certain drawbacks also. The first drawback is the single point failure as far as the control site is concerned. Second is the control site is likely to be overburdened or doing the extra work. And one more problem is there, that the communication link near to the control site will be congested, as well as it can become the bottleneck also. Now the third problem with this centralized solution is the synchronization delay of the algorithm, because as far as the site first releases permission to the control site, request to get the permission, then the control site will grant the permission to the next site to execute the critical section. So as far as the system throughput is concerned, it is going to be less. So that is why we are going to discuss about the token-based first token-based algorithm, which is used to avoid or handle this mutual exclusion algorithm, the mutual exclusion problem. So in token-based, as I told you, a unique token is shared among the sites. A site is allowed to enter into the critical section if it possesses the token. What used to happen that whenever a site is going to request for its critical section, every request for which it is asking for the token, every request contains a sequence number and all the sequence number are maintained at the different site uh, independently. So what is happening that a site increments its sequence number. A sequence number is it's a type of a counter every time whenever it makes a request for a token. Now, the primary function of the sequence number is to distinguish between the old request and the current request. The second thing is that a correctness, as far as the correctness proof of the token-based algorithm, uh, it is going to ensure that mutual exclusion is is enforced. It is not a small thing, because an algorithm is going to give you the guarantee about the mutual exclusion so long as the site holds the token during the execution of the control section. So uh, the proof that token based algorithm is going to happen, it is going to work, it is going to resolve the mutual exclusion problem, because once a site is possessing a token, first it is requesting the token. Once the token has been received, it will be the token will not be given, it will not going to give the release message until it is in its critical section, it is executing its critical section. So it is free from starvation, it is free from any kind of dialogue, because till the site is executing its critical section, it is not going to release the token. So, and the time come when it is going to finish the task of its critical section, it is going to release. And once it releases, it passes the token to the next site who has requested for the token. So the first algorithm of this category, that is token-based category, is the Suzuki Kasami algorithm. Now, as far as the concept of the Suzuki Kasami algorithm is concerned, it is very simple. If a site who does not have token and wants to enter into the critical state, critical section, so it broadcasts a request message, request for the token message to all the sites. Now here the term, the Suzuki Kasami says that it has to broadcast. So broadcasting of the request message is being done by the site who does not have token and want to enter into the critical section. Now what is token? Now token maintains two vectors. The first vector is known as queue of the request sites. It may be possible that many sites are requesting. So all are being put in a queue. It is maintained by, so queue is a part of the token which is being issued. Suppose we have 4 sites, 1, 2, 3, and 4. And currently fourth site, the site number 4 is having the token. And 1, 2, 3 has asked, requested for the token. So when the site 4 is receiving the request from process number 1, process number 2, and process number 3, it maintains the queue, because if it has received the token from the first site, and then from the second site, then from the third site, so it maintains a queue that is 1, 2, 3, just to give the information that first, सबसे पहले 1 will be executed, then second will be, then third will be given chance. As well as it maintains an array, and that array, it is an array which is maintained by the token itself, ln, from 1 to n, and it contains the sequence number of the most recent execution by the site j. If the site j is having most recent execution is 1, so it will be 1. If it has 2, so it will be 2, and so on. Though the process, the site which is having the token is known as holder. So token holder sends the token to the requester. But if that particular site which is having token and executing its critical section, it is inside its critical section, it will not send the token until unless it is going to exit from its critical section. So the token holder will be sending the token to the requester until unless it is not in its critical section. If it is in the critical section, it will not send. It will hold on and put all the requesters in a queue. But once it exits from the critical section, then only it passes the token out of the queue. The top priority is the whomsoever has requested first will be given top priority, and the token is given to them. And once a particular site receives a token, it becomes the token holder. And this token holder can make multiple critical section accesses. Now, as far as the design issues of this algorithm is concerned, the first design issue is the distinguishing outdated request messages. It may be possible. Suppose what is the meaning of outdated request? Now, suppose site 1 and site 2, there are two sites. Site 1, 2, 3, 4. 4 is having the token. Site 1 has sent a request with the request message along with value 1. And after that, it has sent the second request to the 4, that is with the value 2. It has sent the third request with the value 3. And suppose the request number 2, which has been sent by the site 1, is delayed, and request number 3 is received by the site number 4 from the site number 1. And after executing the request of the site number 1 for third request, if the second request is being received by the site number 4, then it means it is an outdated message. Since it has already taken care of the third request, it will not going to take care of the second request which is being delayed. So that is the meaning of the outdated request. And for that, we have to maintain a certain vector, and the format of distinguishing is request JN, that is the jth site making the nth request. Of course, here ith likha hua, this is J. This is the site number, means the process number, site number 1, site number 2, site number 3, and what sequence of requests it has